SAM2 segment anything to model has been in talks on the social media in the tech community. The model has shown great performance, and in this video I wanted to showcase how to set up the SAM2 repository, how to run the code, and go through the code to run SAM2 on videos and see how we can use it for further tasks. Welcome back to the channel, guys. My name is Dhruv, and in this video we're going to start talking about segment anything to model. I'm going to talk about how you can set it up on your computer, and then we would talk about how you can go about using this to run it on your videos. We'll go through the sample code, and this sample code Meta AI has already provided the sample code. We will go over it, run it, and see how it performs. So stay tuned until the end of the video. So guys, to start, let's just understand the high level architecture for SAM2 so that we know what we are getting into, and then we would look at how to set up the SAM2 repository and how to further use the code. So here on the screen you can see the architecture that SAM2 model uses. And if we just read this, right, for a given frame, the segmentation prediction is conditioned on the current prompt. So essentially, for every frame, the model takes in the prompt, which is essentially you give it either a mask, a point, or a box, and based on the input prompt that you give it, it's going to try and segment that thing in the particular image. So for each frame, it is conditioned on the current prompt. But along with that, the best part is that it is also going to look at the previously observed memories. This is the main advantage of SAM2 over the first version of SAM, which was released last year. Not only is it going to segment the objects on as per the current frame and the current prompt, it is also going to keep a memory of what has happened before, and that is how it's able to track objects across different frames. So videos are processed in a streaming fashion with frames being consumed one at a time by the image encoder and cross-attended to memories of target object from the previous frames. So every frame is being processed one at a time by the encoder, but also there is cross attention mechanism wherein it is comparing the particular frame, that particular object with that object which was seen in the prior frames, and it's able to correlate, and it's able to then ensure that there is tracking that makes sense. Finally, memory encoder transforms the prediction and image encoder embeddings for use in the future frames. So here is the image of the architecture, and you can see there is a prompt encoder, there is a mask decoder, there's a memory encoder, and the memory bank and memory attention. These modules are going to do the cross attention and correlate the object in this frame with the previous frames. So that is what the overview looks like. Now, as we've seen that Facebook or Meta has released the entire code for SAM2. So here is the GitHub repository, and this is what we'll use to set it up, right? So the first thing you need to do for installation is to clone the GitHub repository. So literally you can just copy this and clone the repository. Now for this video we are using the Windows subsystem for Linux, so everything is done in Linux environment. So if you're trying to set it up on Linux, you can follow these exact commands and it should work. This is not on Windows, even though the UI is for Windows, but we are running Windows subsystem for Linux, which basically is Ubuntu 24. The cloning step is pretty easy, and after cloning you cd into segment anything. Now one thing that this repository doesn't do is they do not create a virtual environment, but for any task, any new project, any new experimentation that you do, you should always use virtual environments, because otherwise you can end up having dependency issues, and you can screw up some other environment that was working for some other project, and it won't work for that project anymore, because you installed new software, new versions of packages, and that has basically disturbed your dependencies on your system. So how we can create the virtual environment? So here on the screen you can see this command, conda create. So conda is the package manager here, -n SAM2 Python 3.12. So 3.12 is the Python version that we're using. I won't be running this command because I've already done the setup. Once you run this command, the conda environment will be created, and then all you need to do is conda activate SAM2 in order to activate that environment. Here you can see that environment has been activated. Now with that environment activated, let me show you the folder here. So segment anything, I have put the repository here. So here is where I've cloned the repository, and this is the repository, and in here we have the setup files. So in this folder you can do pip install -e dot and that will basically install the SAM2 package for you. It will install every dependency that is required. On top of that, if we go to the instructions, in the repository it says to use SAM2 predictor and run example notebooks, Jupyter and Matplotlib are required. So then we need to run this command. This will just install the Jupyter notebook and the Matplotlib libraries. So if you do that, pip install -e now again guys, I won't be doing this because I've already done these steps, but if you do it, it will run, and once this is complete, then you have the environment set up. Now going forth, all you need to do is go into the notebook section. Here are some Jupyter notebooks that Facebook has already provided, some IPython notebooks, and all you need to do is run this command Jupyter notebook, and it will open, it will basically launch the Jupyter notebook server, which you can open here. And from there we had created a new so if we go into the repository itself, they have provided 3 different notebooks, and these notebooks pertain to automatic mask generation example, image predictor example, and a video predictor example. In this video we'll focus on the video predictor example, right? So we just created a version of our own just for some changes we were making. So here is that particular notebook. Now guys, again, to understand what's going on here, let's just restart the kernel, and we'll start from the top. So the first thing here is just importing the basic libraries, Torch, OS, NumPy, Matplotlib, PIL, image libraries. Here we are just basically saying that we're telling Torch to use float 16 for the entire notebook for all the operations, which is standard. Now guys, one step that we didn't talk about in the repository that we missed was about downloading the checkpoints. So to start, we also need to download the checkpoints. So if we go into this checkpoint directory, let me show you the checkpoint directory. There is a script called download checkpoints. This script is going to it's a bash script which is going to download the SAM2 checkpoints from the internet, from Facebook, and these are all the checkpoints that we have already downloaded, right? So now once we have those downloaded, we can basically load those checkpoints. So here, this function build SAM2 video predictor, it's going to use the checkpoint that you provided, and it's going to set up the predictor based on the checkpoint. So here we are using the large checkpoint. There are different checkpoints, and let me show you. There is a base plus, there's large, there's small, and there's tiny. We are using the large for this particular experiment. You could use any that you like for experimentation purposes. This function is just to display the mask that is created, and this is to show the points that you use as prompts in the particular when running SAM2. Okay, so now for the example, we are using video, and this video is a sample video that they already provided with the repository. This is a bunch of 2 kids essentially in a bedroom who are jumping around, right? And we'll see how it's able to do the segmentation on these kids. Now guys, so yeah, we'll just see a sample image from this particular data. The next step is initializing the inference state. Now what this does is, essentially you have the predictor, you call this function init state, and it is basically going to store the data from that video inside of it. So during initialization, it loads all JPEG frames in video path and store their pixel in the inference state as shown in the progress bar below, right? So essentially SAM2 requires stateful inference for interactive video segmentation. So we need to initialize an inference state on this video. Because there is memory involved, it is tracking the state of things in the video. We need to initialize the state. So this function over here, this call will do that initialization. There are around 200 frames in this video, and it has loaded all of them. All right, so now the first example is we are gonna segment and track one object. So over here, when we are trying to segment and track one object, the first thing is to reset the state. This is not really needed in this case because we just set up this particular predictor. However, if you have already run the predictor once and you want to run it on another task, you need to reset the state because there is memory involved. This function called reset state is going to reset the state so that your predictions that you're doing are fresh and they're not hampered by the memory from the previous task, right? If you remember, we saw that there is a memory module here, and that is the module that keeps track of previous frames and previous things that have been seen in the particular video, right? All right, so now as you know, we need to give it a prompt, right? So we need to give a prompt to our to the model, to SAM2 model, and that's how you give the prompt. So you define a point here as an array. So let's just define 210, 350. I changed it, we were playing around, and then those points are then added into the predictor over here. And here we also define the label, right? So label 1 means positive click and label 0 means negative click. Now why do we need that? Because sometimes what happens is you want to select, you give it a prompt. For example, if I want to segment this t-shirt that I'm wearing, I'll give it a point. It's possible that instead of just segmenting the t-shirt, it segments my entire body as human being. But we just want to segment the t-shirt, right? What we can do in this case is, we have given it positive point over here. We can give it negative points around my face and other parts of the body to tell it that, this is the only area you need to focus on, that's the t-shirt, and everything else is a negative point, so don't look at that. That way, that is the prompt that goes into the model, and model is able to then just focus on the particular things that you want it to focus on. So here we just give it a prompt and we say, it's a positive point, and we run it and see. Here we basically show that point and the mask. You can see that by putting the star, it has we gave it an input of 210 and 350, which is 210 and 350 over here, this star, and it has done the segmentation for that. So it has basically segmented the shots for this boy, right? We have done the show point, called the show point function, which basically shows the star, and show mask function, which draws this mask, which is his shorts, right? Now guys, what if we wanted this model to segment the entire guy, right? And the entire kid, not just the shorts, right? So we can add a second click, right? So here we basically give it another click. We say that, along with 210 and 350, let's just try it here. Along with 210 and 350, also take 250 and 220. So we give it another point. So 210 and 350 is this. We say, you know, take 250 and 220. So 250 would be around somewhere here, and 220 would be here. So maybe there is a point here, right? So let's see what we find. Now again, we will show the mask and draw the point, and you can see, right, here is the second point, and the entire segmentation mask can be seen, right? Now we can propagate this now to throughout the video, right? So there is this function propagate in video, and it's able to then call the predictor sequentially on all the frames in the video and give you the output. So if we run this, it's running it on all the videos over here. Now guys, this is very powerful because SAM1, the previous version, you could give it a prompt, a click, and it would segment the thing. But for every single frame in the video, you had to give it a prompt, it would segment. You have to give it a prompt. So the most important place where, or the most groundbreaking effect that SAM2 is gonna have right away is the annotation platforms. Before, annotation was a pain. In doing annotation for segmentation, you had to go through every single frame, click, 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 use SAM and refine the segmentation masks. Now with this video, you click it once and the object can move anywhere in the scene. It will most likely be able to track that object and do the segmentation for that object, which makes it very powerful. Now you don't have to go through all the frames, and then you can just focus your energy on refining the masks if needed. So for auto annotation and auto labeling, this is going to be very, very helpful. So here you can see, after running the inference, we can see that the model has then done the segmentation for the kid across frames. Even when the kid is occluded and goes behind this girl, still be able to mask it, right? So it's still able to track it. Once it comes back into the frame, it can still be tracked, right? So think about if you are a data annotator and you were to annotate each of the frames of this video separately. Even if you didn't have access to SAM at all, then you would be doing it manually. Now with SAM, you would go through each frame, click on the kid, get the segmentation, refine the box or segmentation mask. With SAM2, this was with SAM1, and with SAM2, you don't need to do anything. You just click it once, define the region, define the prompt once, and then over videos, it's able to do everything, right? So similarly, say you are a data annotator for autonomous driving and you want to annotate a car moving in the scene, right? Before, you had to go through 100 frames, or like say there's thousands of frames, right? Now you do it once, give it a prompt, and it would auto annotate, right? So this is pretty groundbreaking. All right, so then further add new prompts to further refine the masklet. As I've said, right, you can give positive clicks and negative clicks. So in this cell, it's telling about the positive clicks, and here it says, you know, take the point 82 and 415. So point number 82, which is going to be somewhere here, and 415. So in this before refinement, you can see that this is not very good, right? It's coming out to be, the segmentation is not good, the legs are not segmented properly. It says, you know what, we'll add a negative point at 82 and 415 over here somewhere, and then we'll see, you know, with the positive points and with the negative points, if the model is able to do any better. So when we run this, before refinement, this is what we get, and after refinement, this is the point that we have defined for refining it. And now we'll see how this appears, right? So let's try it out, and we now run the propagation again. So while it's running, let's see. So this has completed the run, and now we can see the frames again. let's go to the frame of interest here. So we can see the legs are much better segmented, right? Of course, for that particular frame, there is still some problem. Let me try to find that again. For example, frame number 150. But for the other ones, it's better. So the point is that we can essentially give it positive and negative frames to be able to positive and negative points to be able to refine our segmentation mask. Now, if we want to segment multiple things simultaneously, so here the first thing is to reset your predictor already that you have used so far, because then otherwise you'll have the memory for tracking that boy, but now maybe you want to track the boy and the girl, or they're close. So let's see what we do here. So we do the resetting, and then we have to create the prompts, right? So here for the prompts, so over here, what we're trying to do is we're trying to get the shirts of both the children, and we're gonna find the points here. For example, 200 and 300 is for the kid, for the guy, and then we will define a point for the girl. So let's run this part, and then 275 and 175 is the negative point for the guy, just to focus on the shirt. So step by step we are seeing that it's able to do that, and then we add a positive point for the girl with label 1, right? So now it didn't even need a negative point for the girl. By now it has understood that we are focusing only on the shirts, and it's able to just do it in one go. See, this time the model predicts the mask of the shirt we want to track in just one click without any further negative examples. So this is really powerful, right? So now we're going to propagate the prompts to get the masklet across videos. So again, the same thing, it's going to run it throughout the videos, and it's going to try to figure out and segment and track the shirts for both the kids. So while it's running, this is pretty nice. Cut this section, cut this section. So here guys, we can see the results from frame number 0 onwards. Both of the shirts are being tagged, they are being tracked, and it just works without any prior supervision. Again, if you have any data, any video, you can literally just take that video, split it down to frames using FFmpeg. Very simple way to create frames out of it. You define your prompt, and you can use SAM2 for auto annotation, for auto labeling, for the purpose of another downstream task that you want to do, with zero training, zero fine-tuning, with zero annotation required, nothing. And that's where this foundation model becomes so powerful. Now guys, not only that, you can link or use this model together with other foundation models. Like we have vision language models like Florence 2, which also don't require any training on specific data set. You can tell the model, give it a text prompt in vision, in natural language. So I'm telling it that, in this video, draw a bounding box or pick a point on the shirt of this kid. It will give you a point, and that point can be fed into as a prompt to SAM2 to do the segmentation. Or I can say that in this image, give me the bounding box for the boy. It will give you the bounding box. That's the VLMs are able to do that. You can check out Florence 2 for this. We do have a video on our channel as well. And then that can be cascaded into the input prompt for SAM2 to further do your downstream tasks. So these foundation models with VLMs, with computer vision, vision and language coming together is very powerful for computer vision and for robotics in general. So that's it for this video, guys. That was a demo of how you can set up and run the SAM2 model on your own system. We went through the initial setup to set up the environment. We went through the code to run it, and we've seen how it runs. Hopefully you can use this video as a reference to set up and run cool experiments using SAM2 and use it in your projects, in your products going forth. If you like this video, please hit the like button, subscribe to the channel, and hit the bell icon so you are notified about any new video that we upload. Thanks a lot for watching, guys, and I'll see you in the next video.